Hello, this is my introduction to the basics of real-time VFX in Unreal Engine 4 tutorial video that I'm making. We're going to start in Photoshop. Because we need to make a texture, this is going to be our basic texture that we use as much as we can. So we're going to make a new file, a new document, and we're going to make it 512 by 512. I'm going to make it RGB 8-bit. 512 because it's not too big, it's not too small, it's a good size. I like 512. So we're going to make our background black because black is transparent, and this is going to be our alpha channel. I'm going to make a new layer. We're going to come in here with a little brush and just sort of scribble around, make like a sort of radial, like a star bursty kind of shape. And it's going to look awful, but that's fine because we're going to fix that. That looks good. Okay, so we're gonna bring it in the middle. I'm gonna scale it down a little bit just so it doesn't shoot off the edge, and then we're gonna go up to the best tool in Photoshop, radial blur. We're gonna go to zoom, put it to like, I don't know, 53, and just bam. And we're gonna repeat that a lot. Whoosh, and now that's already looking kind of cool. So we're gonna go back to radial blur. And we're going to change it to spin, lower it a bunch, and just spin it, just to kind of even it out a little bit. And we're going to radial blur it a couple more times. Just because. Okay. That looks pretty good. So we're going to save it. We're going to save it as a targa. And we're going to save it, you ignore that file. We're going to save it as t_burst. That's good, I think, for now. Burst is fine. We're going to save that. Yes, 24 bits per pixel is good. That's fine. We could probably save it to 16, but I don't remember if Unreal can import those. Okay, so now we're in Unreal Engine 4. I've imported our texture that we made in Photoshop, and we're going to make some particle effects. But before we can make particle effects, we need a material, because particle effects are all based on materials. So we're going to make a new material. We're going to go m_master material. It's master material because this is going to be the material from which we make instances for all of our other materials, for other textures and such. I always try and make a master material with as much functionality as I can, so that I don't have to keep making new materials. I only make new materials when I absolutely have to, when it's something so unique that I cannot incorporate it into the master material. So we're going to make a basic, simple master material for the effect that we're going to make later. So we're going to open it up. First things first, we want to go to our material attributes thing, node. And we're going to change it to translucent because it's a particle. We need it to be a cutout of our alpha channel. And masked doesn't behave quite right, so we're going with translucent. And we're going to make it unlit because lit particles are very expensive and unnecessary for the most part, especially for like magic glowy stuff because it's glowing anyway. So we are going to bring in our texture, and we're going to keep this pretty simple. So we're going to need a node called particle color. This lets us control the color and opacity of our texture inside of Cascade, the particle editor. So we're going to make a couple multiplies, and we're just going to use the red channel of this texture, and we're going to bring it over to multiply. We're going to bring the color of particle color over, and we're going to bring the particle color over into this multiply as well. We're not going to bring over our alpha just yet because I want to add another node. So we're going to right click, and we are going to make a dynamic parameter. Dynamic parameter is a super useful node. It basically gives us 4 numbers that we can connect to whatever in the material that we can modify and animate inside of Cascade. We're going to be using it for 2 things. So we're going to name the first one emissive, and the second one erosion. So for emissive, we're just going to put another multiply up here, and we're going to bring this up, connect it like that, and plug it into emissive. This isn't necessary, but it's just something I like to do. I like to be able to control the emissive strength of my sprites separately from the color. It's a personal preference, but I like to do it, so I'm going to do it in this video. I have to rename this erosion. Okay. The second thing we're going to do is alpha erosion. So we're going to make a subtract. We're going to bring down our alpha channel, which is the same as our emissive color channel because it's just a little white mask thing. And we're going to plug our erosion into a 1- and then into B. We're plugging it into the 1- because the default of erosion is going to be 1. And at 1, if we were to not 1- it, it would make this completely invisible by default. But we put the 1- in, it is not invisible. So yeah, I should explain what alpha erosion actually is. First, I'm going to add a clamp because it's nice to add a clamp after this. It keeps things from getting a little wacky. But yes, so what alpha erosion is using particle color, we can fade out the opacity of our sprite, which is good. However, it can look a little cheesy or stilted if you're just going from 0 or from 1 to 0 on opacity, a straight fade out. What alpha erosion lets us do is it lets us eat away at these kind of gray areas around the edge and have it fizzle out somewhat like an ember from a fire. I will demonstrate. An easy way to test animating a dynamic parameter is you go time into sine into constant bias scale, and you just plug it in here, and now we can see how it sort of works. It fades it in like that. So we are going to do this, and we're going to plug it into our particle color and plug that into multiply. And we can stop previewing this and delete this. Perfect. There it is. So that is our material. Next, we're going to go into Cascade, and I'm going to talk about nodes for like a million years. Hello, we're back in Unreal. Now we're going to go into Cascade, Unreal's particle editor. So we're going to right click, we're going to create a particle system, and I'm going to name this P_impact, because I'm going to make a little impact effect later, but first I'm going to explain how this menu works. It's not a menu. I mean, it's a lot of menus. Get the idea. Alright, so when you open up a new particle thing in Cascade, you have this window, a bunch of, like a graph, a bunch of buttons, some menus, and you have all these nodes and stuff, and you have your particle effect, which by default is a bunch of little pluses splurting upwards. I'm going to go through the important bits that I use most frequently, and the things that you might need to make a basic effect, and get started making stuff. I'm not going to talk about the complicated things because you don't need them to start. So we're going to start off with our emitters. So this emitters window is where all of our particle emitters live. You always have a default emitter. If you right click, you can make another one. It will look the same as the first one. We're going to go through this one first though. So you have this checkbox. It lets you toggle it on and off. You don't have to worry about this and the S button. If I had more emitters, it would solo this, like alt-clicking on a layer in Photoshop. So you would only see, the only emitter that would be visible is the one with the S checked. If you go down to required, this is a module that you will always have. You cannot delete it. Down here in our details, it gives us all of the parameters and settings in each node. You can see that they change depending on what I have selected. I'm going to go through the important ones. So in required, we have material, which is a little self-explanatory. It lets us choose the material that is displayed on our sprite. Give it a second to load, and now look, it's that material that we made. Our texture is instead of the plus. The way sprites work is they are just single quads that we are putting a little picture on. If I go to wireframe, you can see all those little quads spreading out. And when we go back to the normal view, the normal view, you can see that it's just like putting a texture on a quad. That is what most particle effects are. I zoomed in. All right, so emitter origin is, this is 0. If I put 25, it moves the emitter over 25 on X. That's straightforward. Emitter rotation is the same thing. Screen alignment is very important. It defaults to PSA square. When I showed you that quad earlier, you could see that it was a square. It was a perfect square, same length on all 4 sides. If it is set to PSA square, it'll always be locked to that square shape, no matter what. You cannot make it a rectangle. PSA rectangle, however, will let us do that. I will demonstrate this a little later. PSA velocity is the third one. It's hard to show it. I'll show it a little more later. But essentially, it will make it so that the y-axis of your quad will always, or sprite, will always be pointing in the direction that the sprite is moving. So right now they're all moving up. So they're all pointing up. So it's hard to see what the difference is. But I'll show it better later. Right now, we're going to just keep it on square. There's the other ones I rarely, if ever, use, so you can safely ignore them. Square, rectangle, and velocity are the 3 most important, most useful screen alignments. You don't have to worry about those 2. Use local space is very important. So we're going to shift over to our actual world here, and we're going to drag our particle effect in. I don't know why I dragged in twice. I think it's because I'm lagging because I'm recording. All right, so we're going to select this, and we're going to drag it around. And as you can see, the sprites are trailing behind the emitter origin because they are staying where they are spawned in world space. This is useful for, like a projectile or something that moves and you want it to trail behind. But sometimes you don't want that to happen. Say if you have some weird magic energy swirling around a character or something like that, you want to check use local space. And now, if I drag it, you can see that the sprites are not trailing behind because they're locked into the local space of the emitter. That is a very important checkbox. I'm going to leave it unchecked for now. Probably going to check it back later. Kill on deactivate just means that your emitter will be destroyed when it is deactivated in Blueprint. Kill on completed will be if the particle is finished, it will die. Sort mode you can ignore for now. Same thing with all of these. Duration is very important. Emitter duration is how long the emitter lasts. So right now it's lasting for 1 second, and then it's looping, it's restarting. Emitter loops is how many times it will loop that 1 second of emission until it stops. So say 0 means it'll loop forever. So that's why it's a constant stream of particles. If I were to say 1, you can see it sprays for 1 second and stops, and it restarts in cascade. But if I were to drag it out here once more, I shouldn't have deleted it actually. You can see that once it finishes, it's stopped, and I have to restart it in order to have it play again. So this is very useful for if you need something that only plays once. You will change it to 1 or 2 if you want it to play twice, etc., etc. I'm going to leave it on 0 for now. Actually, for the sake of my example, if I were to change this to 3, it would spray for 3 seconds and then stop. I'm going to leave this at the default values. Delay is, like it says, a delay. Say I have an effect that involves halfway through the effect, it starts spraying smoke out. I would just say, okay, well, 2 seconds in, put 2 here. This is based on seconds. Emitter duration is also based on seconds. And it will just delay the start of this emitter by 2. You can check delay emitter or delay first loop only. So if you wanted to constantly spray smoke after the first 2 seconds, you check that so it'll only delay it for the first time it sprays. Whenever there's a thing low and then a use range, it just makes it so that if you check that and put a number in low, it'll choose a number between the two. I don't use a range very often, so you probably won't need to do it. SubUV SubUV is how you move through a flipbook or a sprite sheet or there's a third word. SubUV is the third word. I'm going to talk about this later. It is important, but it can be a little hard to demonstrate without the proper equipment. And the rest of this you don't really have to worry about. So that's the required module. It is the densest module in Cascade by far. So now we're going to go down to spawn. All right, so now we're going to talk about the spawn module. There's a lot less to do here, luckily. So spawn is pretty easy and understandable. We have rate, which is the rate at which we are spawning particles. Right now it's set to 20. You can see it as a constant stream. To be completely honest, I'm not entirely sure what this number is based on. It is not 20 per second. It's a little abstract, but you just mess with it. I would try not to go over 85 because it gets expensive. But if I put it to 50, it's spawning more. If I put it to 25, it's spawning about the same as originally. If I put it to 5, it's spawning very slowly. That's what rate does. It is literally the rate at which we're spawning particles. If I put it to 0, nothing's being spawned. We can come down here to burst, and again, like the name implies, it is how we create a burst of particles. Whereas rate is spawning particles constantly, burst will spawn in a designated number of particles all at once. So, say we want a burst of 15 particles to pop out at once. There we go. We can set a delay on the burst as well, and we can have multiple delays. So we have one at 0 and then one at 0.5. There we go. So that's how burst works. You can delete them. I'm going to leave it on a constant stream for now. Okay, so next is lifetime. Lifetime only has 1 or 2 numbers depending on this distribution drop-down menu. So I'm going to start by explaining this. If you go to float constant, it means that you have one single number that you will always have. Essentially, the lifetime will always be this number. 0 lives forever. We never want that. It's not good to always have particles never die. So you always want to have a lifetime. Right, so at a lifetime of 1, this is in seconds. Each sprite will live for 1 second and then die. If we make it 2 seconds, they all live for 2 seconds and then die. If we make it 0.2 seconds, they all live for 0.2 seconds and then die. If we set it to constant curve, we can animate that constant. It doesn't work on certain modules like lifetime, but I'll be showing off constant curve a little later when we get to color over life. You can ignore particle parameter. Uniform is a range. So say I have a min of 0.2 and a max of 1. Now it's a little hard to see, but some of the particles are dying down here, and some of them are dying up here. Some of them are living for 0.2, some of them are living for 0.1, and some of them are living somewhere in between that. That is what a uniform is. It is a range. I don't know why it's not just called distribution range. Yeah, that's lifetime. It's exactly what it says. It's the lifetime of the particle. Initial size is also exactly what it says. It is the initial size of the sprite. When your screen alignment is PSA square, only the X value will matter. So I'm going to say the max is 75 and the min is 25, and you can see that the size is fluctuating upon spawn. 30, you get a little, there's a slight deviation in size. 45, it's a little more noticeable. Let's say, you know, I put something crazy here, like 2000, and nothing changes because it's locked to be a square, and the square is based off of X. However, let me bring this to something a bit more reasonable. If I were to change our screen alignment to rectangle, you can now see that it is spawning it as a rectangle. So that is my demonstration of that. And initial size. You can change the distribution to constant here as well. Yes. Initial size, not much going on. Initial velocity, again, it's exactly what it says. You see how they're moving up? That's because the initial velocity has a value of 100 to 50 in the z-axis. If I were to change this to 200, some of them would move much faster. Some of them would still be moving at 50. Again, this is sort of an abstract value. It's moving 200 fast in the up. So it's a value that you have to play around with to get what you want. If I wanted to spread out more, I could up this to 25, negative 25. 25 is positive x, negative 25 is positive, or negative x, same thing with y. You see they're spreading out a little more now. That's initial velocity. Use extremes will make it so that it is either the max or the min and not an in-between value. I almost never use that. Color over life. This is when we start getting into a constant curve. So you can see there's a lot of things here now, but it's actually pretty easy, so don't get too scared. In value. In value is your point on the timeline. 0 is the beginning of the particle's lifespan. 1 is the end of the particle's lifespan. So the in value for the 0 point is 0, which means at the beginning of the life, our particle is going to be red. It's going to be red, not orange. No, it's going to be red. Or pink. It's going to be a pinkish red. And then at the end, 1, we're going to make it blue or purple, a purplish blue. And you can see now our particles all start red, pinkish, and transition into that purplish blue. If we want, we can add more points. You can either click this plus to add one at the end, and because we have two 0 values, it gets confused and unhappy. We're going to say this is 0.5, and this is 1, and we're going to change this value to yellow, orange, yellow, whatever. And you can see now it goes red, blue, yellow. The other way you can add something is if you want say I want another value between these two, I can go click insert, and it will add one above whatever drop down you are pressing insert on. So we're going to say 0.75, and we're going to make it green, like teal, whatever. And now I'm going to make the lifetime a constant of 1.5 because it makes demonstrating this a little easier. And now you can see that the colors are shifting as it moves up. I'm going to put the velocity down also. There we go. Now it is easier to see the color change. That's color over life. If you want it to just be a single color, you can set it to a constant. If you, I don't recommend uniform for this. It doesn't work quite right. The other thing is alpha over life. As you can see, it starts completely opaque, and I don't know why it's lagging like that. But it fades out over time. That's because at the beginning, 0 of the particle's lifespan, we have a opacity value of 1. And at the end, 1, we have an opacity value of 0. This node is talking directly to that particle color node in our material. So if that node isn't plugged in, this will not work. If I wanted it to not fade out at all, I could set that to 1. and now they just pop out at the end of their life. They just die. That doesn't look very good, so I'm going to keep it fading out for aesthetic purposes. That is color over life. So those are the default nodes that every emitter that you create will start with. You don't always need all of them, but you usually need lifetime, initial size, and some sort of color. So if you right click on your emitter, you'll get a huge drop-down menu of all of the other modules you can add. So if you go to emitter, these are just options for the emitter. They don't add anything. You can rename it. You can duplicate it, which makes a clone. You can duplicate and share, which I'm actually done. Oh, I believe this, yeah. Duplicate and share, I've never used this button before. It makes a clone of your emitter, and it also makes instances of all of the nodes on your emitter. So if I change a value on any of these, it will automatically change it on the second emitter. I don't use that. Well, I use the instances, but I don't use duplicate and share. I don't think I've ever pressed that button. Delete emitter will delete your emitter. I don't want to delete this emitter. Export emitter will, if you have another particle system selected in the content browser and you use export emitter, it will copy the emitter from this particle system to the other particle system. Export all will do that for every emitter you have in the particle system. You don't have to worry about the particle system things. So type data is very important. The default type data is a CPU particle or a CPU sprite. This means that it basically means that your emitter is running off of the computer's CPU. I'm not really going to explain what that means because it's complicated and I don't feel like explaining that. It's not really a problem. I'm not going to talk about these now because I don't think they're necessary to make a simple particle effect and to kind of learn what to do. Mesh is probably the most useful of these that I use the most, but I'm not going to talk about it right now. So we're going to talk about acceleration instead. Acceleration and constant acceleration they both kind of do the same thing. You can sort of use either one. I'm going to use constant acceleration. It's the one I use. I pretty much always use this. This will constantly add an acceleration value to an axis of your choice. I'm going to say that I want to constantly add a negative 350 acceleration to my z-axis. And now you can see that the sprites are kind of popping up because of our initial velocity, but then the acceleration kicks in and they start going downwards. Acceleration is different from velocity because velocity is a static value. It's going in that direction. It's going 200 in the z-axis. Acceleration, like the name implies, is constantly adding velocity. So it is constantly adding 350 in the down z-axis. If I were to lower it to maybe 100, you can see that it comes up a little higher and then starts coming down. It's useful for things that fall. Let's see. We're going to go back to acceleration. The other one here that I use a lot is drag. What drag does is, it's hard to see exactly because my frame rate is being a little weird again because of the recording. But what drag does is it applies drag to your sprites. What's drag? Drag is essentially air resistance. The velocity starts out at, I'm going to up it a little bit. We're going to say 150, 125. You can see it starts out going fast and it slows down over time. That's what drag does. It's kind of a reverse acceleration. If you have a higher number, it slows down more faster. 2, you can see it slows down here, whereas 1, it was hitting that really slow point until more up here. Drag's really useful. It adds a nice curve of movement to anything you make. What is next? That's the important ones in acceleration. You don't have to worry about attraction, camera, collision. Next is color. I already talked about color over life. It will pretty much be your go-to. Initial color is the same as color over life, except you cannot animate it. I will usually only use color over life because I almost always want to animate my alpha, and you cannot animate your alpha in initial color, nor can you animate your color. And I pretty much always want to animate one of the two, so I stick with color over life 99% of the time. That might be a bit of an exaggeration, but I think 85% of the time is pretty realistic. You don't have to worry about event or kill. I already talked about lifetime. You don't have to worry about light. Location has several important modules. The first of which is initial location. So if you have initial location set to vector constant, it behaves identically to emitter origin. If I wanted to move this over 25 on X, it will move it over 25 on X, with our 0 being around here. What makes it different is that if I set it to vector uniform and I check the 3D draw mode to visualize my emitter, which is a box on, I think, all of the location stuff. And I'm going to say 25, 25, 25, negative 25, negative 25, negative 25. It creates a box. And our sprites are now spawning from a random point within this box. That's initial location. You can animate this on a curve. Let me add a couple here. We're going to say 25 and at 0, and then at 1 we're going to go negative 25. And it'll move. The visualization won't move, unfortunately, but you can see where it's moving. You can also do a uniform curve, which will animate the whole box. I'm not going to demonstrate that because it can be a little time consuming to set up, right? Yeah, that's initial location. It's basically a box that you can move. The other useful thing here is cylinder. Cylinder behaves essentially the same as the box of initial location. I'm going to turn on the visualization. It creates a cylinder. It's spawning your sprites at random points within the cylinder. You can adjust the radius of the cylinder, make it big, make it small. You can adjust the height of the cylinder, make it tall, make it short. The height axis will let you change which axis the length of the cylinder is going down. We're going to leave it at Z for now because I like up. All of these checkboxes let you turn off the different axes for spawning. So if I uncheck positive Y, you can see that now in the positive Y half of the cylinder, we're not getting any sprites spawning. Surface only, like the name says, makes it so that now the sprites are only spawning on the surface of the cylinder off of these faces. I'm going to turn off initial velocity real quick. Like the checkbox for the top of the whole emitter, you can turn off individual modules by unchecking their little checkbox. So now they're just spawning stationary on the edge, and I'm going to turn on velocity. Now you can see that they are radially shooting out of the cylinder. I believe you can think of it as it's based on the normal direction of these faces. If the normal is oriented directly out from each face, the velocity of the sprite is inherited from that normal direction. I don't know if that's actually how it works. I doubt it is, but you can think of it like that. The velocity scale is the strength of the velocity. This is 1. This is 5. It's very powerful. The strength of this velocity is based on the size of the cylinder. So if I were to make this much larger, you can see that now 5 is much stronger. 1 is shooting out what 3 was at the initial, the 50 scale. So keep that in mind. You can animate the start location on this too, or just change it. Now it's moved over 25. It's the same as all the other start location things. So that's cylinder. Sphere is also in here. It is identical. That's not right. Sphere. It is identical to cylinder, except it's a sphere instead of a cylinder. I can turn on velocity. It behaves the same. The only difference is I can't select the length or the height direction because it's a ball. It doesn't have that. Everything else is the same. I can turn off. Oh, wrong button. I can turn that off. It's no longer spawning the x-axis. It's the same. There's also triangle. It's also the same. You don't really have to worry about any of these other things. Pivot offset is useful. I will talk about it a little later. Rotation is very useful, and I use it on almost everything. So initial rotation is what you will most often be using. So now, if you look at these sprites, I added initial rotation, they are no longer all the same sprite. Or they're still the same sprite, but now the rotation of the sprite has been randomized. If I uncheck it, you can see they're all facing the same direction. It's really obvious it's the same picture over and over and over. When I check it, it becomes a little harder to tell that it's just the same texture being spawned a million times. The way the settings work is it is a 0, it goes from 0 to 1. 1 being 360 degrees, 0 being 0 degrees. So right now, the initial rotation is being randomized from 0 to 360 degrees. It doesn't really make sense to go above that because that is a complete rotation. So if you put it at 1.5, it's essentially identical to being at 1. If you want it at 0.5, you can lock it to only rotate certain, to halfway. Initial rotation is super useful because it helps hide the fact that you're using the same texture to create more complicated shapes. The next one is rotation rate. You can ignore these. So rotation rate looks basically the same as initial rotation. But now you can see that not only is the initial rotation being randomized, but they are also spinning over their lifespan. That is what rotation rate does. It gives them a random rate of rotation over the lifespan. The way it works is it's from 0 to 1, like initial rotation. 1 is 360 degrees, 0 is 0 degrees. This is based on the lifetime. So 1 means that your sprite will rotate exactly 360 degrees once over the lifetime of the sprite, which is 1 second right now, or 1.5 seconds right now. 0 means it won't rotate at all, and it'll choose a random value between that to rotate. If I were to say 0 to 2, you can see some of them are spinning very fast because they're spinning 720 degrees over its 1.5 second lifespan. We are going to add another one, which is rotation rate over life. This lets us add a fall-off 2-hour rotation rate. So right now, by default, it goes from 1 at the beginning of the lifespan, or lifetime, to 1 at the end. But if we were to change this to 0, you see that they're spinning at their normal speed at the beginning, but by the end, the rate of their rotation has fallen off to 0 because we're animating the rate over life. This and rotation rate pair together very nicely to create complicated movement. After rotation rate, you can ignore orbit. Orientation is a situational module. It defaults to none, which changes nothing. And this dropdown gives you a bunch of options like X, which means lock axis will lock the direction that your sprite is facing. Normally sprites, if I were to deactivate this, they are camera facing. They will always face where my camera is, no matter where I am. If I turn it on and lock it to X, it will only be facing towards X. Or Z. Only looking down. There's also things like the rotate Z, where it's still camera facing, but only on the Z-axis, so it will not turn up to face me. Lock axis is fairly situational, but it can be useful. Parameter is that dynamic parameter I was talking about earlier. So if you go to parameter, dynamic, you get these drop-down menus. It's going to say parameter name none. That's because you have to right-click and refresh module, and then it will look for that name that we gave the parameters in the material editor. So this is our emissive. If I crank this up to 25, you can see that now our emissive is very bright and glowy. What's useful about this is it lets me make a constant curve at 2 points say at the beginning 0, we have 25, and at 1, we have an emissive of 1. So now our glow fades off over the lifetime. I can even have this point to 0.5, so now halfway through the lifespan of the sprite, the emissive fades off to 1 from 25. That is the power of dynamic parameter. I can even have it start at 1, at 0.5 be 25, and at 1 be 1. So now it starts not glowy, becomes glowy, and then unglows by the end. I can also come down here to erosion and create a constant curve, add some points. We're going to say that at 0, it's going to be 1, which means it is not eroded at all, and at 1, it's going to be 0. And you can see that in addition to the fade out from the color over life, we're also getting that little erosion that I demonstrated in the material, where it kind of shrinks down the alpha channel. I can also just have it go halfway. If I set this to 1, so we're only getting alpha erosion, it's a little easier to see. Not all textures erode super well. This one, because the middle core is very much completely white and opaque, it doesn't erode super great. That's just what happens with this simple kind of alpha erosion that we're using. But it adds a little bit of extra motion, so I'm going to keep it on. Yes, so that's dynamic. It's our dynamic parameter. Size, I already talked about initial size, but the other one here that is very useful is size by life. Size by life lets you animate the size of your particle over its lifetime. So right now, at default, it's always 1. This is based off of your initial size. It is a multiplier. So if I were to say we want it to be size by life from 1 to 2, you can see that it starts at its normal size, and it doubles that over its lifetime. I can say we want to start at 0, and it will multiply that by 0 at the beginning, so it doesn't exist essentially, and then multiply the initial size value by 2 at the end of the lifespan. That's size by life. You can also have stuff like 0.5, you can say 5, make it really big, and then 1. That's a little too big. Hurts the demonstration a little bit. There we go. You can see that they start 0, become twice as large as normal, and then shrink back down to 0 at the end. That's size by life. Spawn, you can ignore that. SubUV I will describe later, and velocity, you really only need to worry about initial velocity, which I've already talked about. So that is all of the emitter nodes that I use frequently and I think are the most useful. There's other useful ones, but they're a little more complicated, and you don't really have to worry about them until you're comfortable with the easy stuff. So next I'm going to make a actual little effect in Cascade, and you can follow along. Okay, so now we're gonna make a little effect. We're gonna make like a little hit impact for like a laser or a sword or something. I deleted that emitter that I was using for demonstration. I'm gonna make a new one. So we're gonna make a new one. This is our new emitter. As you can see, it looks just like that emitter we started with so very long ago. First things first, I'm gonna name it. It's always good to name your emitters, because if you have like 20 of them and they're all called particle emitter, it can get kind of hard to figure out what is what. So we're going to name this Flash, because this is going to be a quick flash of light in the center of our little hit impact. I'm going to go and I'm going to set our master material so we have that little texture. And I'm going to set our emitter loops to 1 because I only want it to happen once. I'm going to go down to spawn and turn our rate to 0 because it's going to be a single flash of light, and I'm going to spawn 2 of them. I'm spawning 2 of them because I want it to be random every time, and I want the direction of those little flares to change. And if I have 1 that rotates, you can kind of tell that it's just 1 that's rotating, but if there's 2 that are stacked, it becomes harder to tell. I want to get rid of velocity because it's an impact. It does not. I don't want the flash to fly upwards. That doesn't make sense. So it's always good to sort of check the size of stuff in the actual world, because this looks like oh yeah, that's a great size in Cascade, but in the real world, it's just sort of. I think I brought in 2 again. Yeah, I did. It's not very big, so I'm going to set this size to 75, and I'm going to give it a little bit of variation, so from 75 to 65. Get a little bit of that lag again. We're going to go 85, from 75 to 85. All right. Yeah, having both windows like that, my computer is not happy with, so I'm going to stay mostly in here. Right, so we're going to set some colors. We're going to make it purple, because I like the color purple. I think it's a nice color, like a dark. We'll make it kind of like a... We're going to set an emissive later, so that's good. And it's going to turn reddish by the end. Yeah, there we go. That's our hit impact. You might be thinking, wow, that doesn't look very good, but it will. So we're gonna just add some initial rotation to it. Yeah, add that variety that we like. And so this is a powerful impact. It's lasting for a second right now, and I think that's a little too long. So I want it to last from 0.15 to 0.2. Now it's nice and quick. Bam, bam, bam. The shorter something lives, the more energy it has, generally. Figuring out good lifetime numbers is sort of just something that you get a feel for as you mess around with it more. I know that quick flash is generally in this range. That's just because I've done it a lot and I think it looks good. So yeah, just you mess around with these numbers until you sort of get a feel for them. That's kind of everything in here. A lot of it is just testing out numbers, seeing what feels right. So we're going to add size by life because it'll add even more energy. So we're going to have it start out at 1, and we're going to have it grow to 2.5. And I'm going to leave it at that for now, because if you have it, say, at 0.5, or 0.3 even, because we want it to grow really quickly, but and then at 1 shrink back down, the energy, instead of bursting outward, bursts out, but at the end of the day, it's getting sucked back in. That works for certain effects, and this sort of curve that goes like, woo, or in this case, it's actually like, woo, that works for a lot of effects, but for this case, we want the energy to just be shooting outward. So we're going to delete this, and we're just going to have it go from 1 to 2.5. You could have it go from 0, start from nothing and burst out, but because our lifetime is so short, it's hard to see it grow from 0 to 2.5. So your brain will sort of fill in the 0 to 1, and then we have actual growth from 1 to 2.5. Yes, that is why I have, that's my logic for having those numbers. Again, it's something you can play around with, get a feel for. My frame rate is really bad right now, so I'm stalling for time while it gets a little better. I don't know if it will. This is because I'm recording in 4K. That was my bad. But it's too late to change now. It's actually not too late to change. I'm going to change that. I'll be right back. Okay, I'm back in a lower resolution, and our frame rate is good now. So here is where we are right now. It's a little burst of energy. I am going to add the dynamic parameter. I'm going to get our names real quick, and I'm going to animate our emissive. We're going to say we're going to go from 25 to 1. Bam. Now, at the beginning, it's bright and powerful, and that bright power fades out because it loses it as it bursts out. Also going to alpha erode because I kind of just always alpha erode. It's good. There's no reason not to. Now we got that little bam. A little bit of alpha erosion. It's not super noticeable, but good enough. I'm going to actually add one more to our count to 3. There we go. Bam, 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 bam. I think that looks pretty good. I actually might change this to a 0.5 instead of a 1, just to give it a little more range to grow. I think I'm actually going to increase that range a little more. Just a little. There we go. Now it really feels like it's bursting forth. So I want some, I want to make some, I guess, lines that fly out like flash, flash, flash. You'll see what I mean when I make them. But I just want to add more directional elements that feel like it's really bursting out. So I'm going to create a, actually, for this, I'm going to duplicate this emitter because I already have some things set up here that I want to not have to reset up. So we're going to use this same material, but we are going to use PSA velocity because I want to grow these lines in the direction that they are moving. So to do that, first things first, I need to add a sphere. And I'm going to make it very small, make it the size of 2, and give it velocity of 5. And you can already see that we're getting, I actually think that the size is even a little too big at 2. We're going to bring it all the way down to 1. You can already sort of see what I'm going for here. Because it's velocity now, it's already inheriting our y values because it's no longer locked to being a square. So I'm going to set our x to be pretty similar to one another. I'm going to set our y to go from 50 to 100, which is a pretty big range. But as you can see, it gives us some variety in terms of the well, actually, no, they should be much higher than the x. So our low is going to be 75, and our high is going to be 175. It's not perfect, but we're gonna make it work. Size by life is actually the way it's set up is probably the reason that is looking weird. There we go. That's a little more like what it's supposed to look like. So we're gonna go back to size by life, add a new one, a fresh one, and we just want it to go from 0. And at the end, we want it to be not just 1 on x and 1 on y. We want it to be 1 on x and 8 on y. Now it really shoots out. That's what we want. We also want to spawn a lot more. I'm going to spawn 8 of them. I'm going to spawn 6 of them. Yes, 6 is a better number, I think. So now they flash out like that. Now, so the origin, the axis, right, or the pivot point is in the dead center of that square or rectangular sprite. And size by life is scaling based on that pivot point. I want the pivot point to be at the bottom of the y-axis to shoot out these rays. I don't want them to shoot out in the same direction on both sides. I want every direction to be unique. To do that, I'm going to go to location and to pivot offset. I didn't really talk about this earlier. I'm going to talk about it now. This lets you move the pivot point on your sprite. So I'm going to move it negative 0.2 on x. So I'm going to move it down 0.2. And you can see that that's leaving a little gap. So I'm going to do negative 0.1. And that is pretty much exactly what I want. As you can see, if I turn on the flash to hide that middle part, it's especially if I go in here. Ooh, there we go. Now they're all shooting out in unique directions, and I think it looks pretty cool. I am going to make these last slightly longer. Let's say 0.2 to 0.35. That's too long. 0.3. Yeah, there we go. And they are a bit long and wide right now, so I'm going to bring this down to 25 and this down to 45. And you know, I think that this should be 0.25. There we go. I'm going to change the colors a little bit. I'm going to make it more purple at the end, just because I don't like it being exactly the same as the, make it like super purple in the beginning. I don't want it to be exactly the same. I don't really like that. I'm going to make it a little more pink. That's probably going to end up being pretty similar to the normal one. It is. See, I didn't rename this, so now I'm getting confused as to which one is which. So let's rename that right now. We're going to name this lines. That's not a great name, but it's enough of a descriptor. I'm going to lower this to 120 because they're a little too long. Drop our size by life down to 6. Rename it again because it didn't stick. If you see me moving them around like this, it's with the left and right arrow keys. Things to the left tend to be above things to the right. It doesn't always work, as you can see. You can see the radial lines through the flash, which is what I am displeased with. I think I'm just going to add more to the flash. It hides it a little better. I am actually going to use a node that I said I wasn't going to talk about, but I'm going to talk about it. Camera offset. Camera offset is actually a pretty simple node. All it does is it will... like I said earlier, sprites by default are camera facing. They're always looking at the camera. So camera offset will just add an offset to the sprite in the direction of the camera. So now I have a 1 offset on this, which means that it's always going to be 1 unit closer to the camera than these lines, just by the nature of camera facing stuff. I'm going to up it to 3. Because I really wanted to draw way in front. And now you can see that it does draw much more in front of those lines. You can see the lines because they have a slightly longer lifespan, but that's fine. I'm okay with it. I think it looks good. So that's a very, very simple hit effect. I want to add a little bit more pizzazz to it, so I'm going to add a shockwave. So this texture isn't great for a shockwave. In order to make a shockwave with this, I would have to spawn a ton of them in a radial fashion shooting outward, and that's kind of expensive and not really something I want to do. So we're going to make a new texture. We're going to go into our old friend Photoshop. We're going to make a new 512 by 512 RGB color texture. And we're going to invert our thing again. And we're going to set up a new little thing. We're going to make a circle, put it in the middle, and we're going to fill it with some white. Because I changed my resolution, Photoshop is a little messed up, but I don't think it'll be a big problem. So we're going to resize this selection. We're going to make it a little smaller than that. A little smaller than that. There we go. And we're just going to invert our color. We're going to make that black. Doing this on the background, which is not very smart, and it's probably going to not end well for me, but it's fine. So like before, we're just going to kind of break up this inner circle a little bit with some scraggly directional-ish lines. It doesn't have to look good because we are going to go get our old friend radial blur. Radial blur. It's on my other monitor right now. Here we go, radial blur. And we are going to zoom. We're just going to zoom. Zoom, zoom, zoom. And we get this little bit of, like, I guess a nub. I don't think that's really what it is, but we're just going to take a brush, not with white, we want to draw in black, a very soft brush, and we're just going to kind of break up this outside also. Because I don't want a hard edge on this at all. And now we're going to radial blur it more. That's one too many. Maybe too many. Because I also want to go back to radial blur and spin it just a little bit. Never mind. I like the streakiness of this. It feels very radial and powerful and directional. So yeah, that will work for our texture. We're just going to go in here and save it as T_shockwave. Yes, and we're going to go into Unreal Engine 4 and we are going to import the shockwave, and we are going to right click on our material, create a material instance, name it MI for material instance, shockwave. We're going to open that instance and we only have one parameter, and we're going to change that one parameter to be this shockwave, and that looks pretty cool. So we're going to go back into our particle, and I'm going to duplicate this again. I'm going to name it shockwave, and I'm going to leave it above the lines but below the flash, and I'm going to just change our material to the shockwave. Let me solo that. I only want to spawn one shockwave because it has a very distinct look. I want to up our lifespan by quite a bit, 0.2, 0.3. Yeah, you see, that's looking nice. I'm going to make it much, much larger. I'm going to make it go to 175. That's 217. 175, and our minimum is going to be 165. I don't want a lot of variation in the shockwave, but I do want. I also don't want our camera offset anymore. So we're because this texture has a lot of grays in it, it erodes very nicely. You can see if I were to turn off alpha erosion, let's just put this at 1, there's a huge difference. I think it is eroding a little too much, so I'm just going to have it erode at 0.5 by the end, because I want to keep more of the shockwave than we were getting when it was completely eroding. So that looks pretty cool. I'm going to unsolo it, and bam, now we have this wave of energy that bursts out. Bam, 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 bam. That's pretty cool. Yeah, I think that looks pretty good. So there's one more thing I'm going to talk about. This is a very simple effect. It's only 3 emitters, and there's a lot more we could do to really polish it up. I still don't like how much of the lines you can see in the middle, for example. Oh, pressing spacebar will replay your effect. It's a nice little shortcut. I'm just kind of tweaking some numbers. Because I can get a little anal about stuff like this. Yeah, I didn't want these to have the same lifetime as the flash in the middle, but I think without it, you always see the sort of ends of them in the middle. So Tough break from me. If I were to spend more time, I would add another element that lingers longer than these. Let's just do it. Let's do it. We're just going to do it. It's 100% freestyle comedy. All right. So new particle emitter. We're going to go back to that little sprite. Master material. We're going to, here, I already have sphere. Alt and drag will make a copy of a node. Shift and drag will make an instance. I explained what the instances are before. Anything I change here will be inherited by the all other sphere pluses. But I don't want that to happen because I want this to have a radius of 5. Oh, I need to reset my emitter loops. And I want to change this to a burst. I'm going to burst out 25 of these little guys. I'm going to get rid of my velocity. I'm going to make them fairly small. I'm going to keep that 25, but I'm going to make our low 10. And yes, sphere, I want our velocity to be a little intense. I want a pretty powerful burst. Because we're so small, I have to actually get a pretty big number. Reduce our lifetime to 0.25, 0.35, so they last a little longer than the rest of it. Let's bump this up to 10 maybe. This to 25. I want some pretty powerful speed on these. 4. 0.2. Give it more of a range on that. I'm just gonna clone this color over light since I don't want to have to play with the color a lot. And I'm also gonna clone this dynamic because it's easier than right-clicking. I'm gonna make it more emissive, and I'm going to remove our alpha erosion. There we go. I'm actually gonna make them smaller. They're too big. 15. There we go. Bam, bam, bam. And one more thing I want to do. That's right. I want to add drag because I want them to shoot out very fast. I'm actually going to increase this to make them shoot out even faster and then slow down. Make it extreme. Put that all the way up to 50. There we go. Now all of these little sprites burst out and slow down. Just adds some more motion. I think that added some nice sort of visual clutter there, but in a good way. One more thing I'm going to do. I'm going to name these sparks. One more thing I'm going to do. I want to talk about SubUVs. So imagine if these little lines were actually lightning, because lightning's really cool, right? We're going to make a little lightning flipbook or sprite sheet or SubUV. So we're going to go back into our old pal Photoshop, and we're going to make a new texture. Because this is going to be essentially 4 textures, we're going to go with a 1024. All right, so we have our 1024. We're going to make the background black. But what we're going to do is we're going to divide our canvas into 4 quarters using these rulers. And now we're just going to draw out some flashy lightning bolts, like, oh, I'm still on black. There we go. Like, zip, zap, zip, zap, 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 zap. I'm not using the brush. Interesting. My hard drive is broken. It's not broken, it's just full, which is an issue. But it's okay, because I was prepared for this, and it turns out that, oh look, imagine I drew some really cool looking lightning bolts. And, oh look, here they are. I drew them in advance, because lightning takes some time to draw. I think when I made these, I just took pictures of lightning off Google or textures.com, and I made alphas out of them. Royalty-free pictures if they were off Google. And yeah, so now I have these lightning bolts. I made these a long time ago, but I didn't want to spend time mid-tutorial to make new lightning. So I have this cool lightning. We're going to go and make another material instance. It's going to be called mi_lightning. lightning underscore 2x2. I like putting the dimensions of the flipbook in the texture and material name because it lets me just see what the size of flipbook is at a glance. This is 1.2 by 1.2 or 1.2 by 1.2 for a total of 4 pictures. So we're going to go in here. We're going to change our texture to the lightning. And we're going to come over here. So I'm going to change this texture from the master material to our lightning material. I'm going to solo it so it's easier to see what's happening. And you might thinking it's actually really hard to see what's happening. That's because right now we are displaying this entire texture, all 4 pieces of lightning on each of these tiny, skinny, thin sprites, or cards, whatever you want to call them. I think they're both sprites and cards. So we need to go into required. I remember this SubUV section. Come on, Unreal. All right, the SubUV section. I will explain it now that we have a SubUV material and texture. So interpolation method, there are 4 options and none, which is your 5th option. Linear will plate through your book 1, 2, 3, 4. It'll cut between each image. Linear blend. Where's my SubUV? Hello, Unreal Engine 4. My good friend. Come on, buddy, you can do it. You got this, computer. Oh boy. Oh boy. No, we're good. We're living. Okay. I don't know why it's slowed down so much, so quick. It's fine. Linear blend is the same as linear, but it will fade between the pictures instead of cutting directly. Random will randomly choose at spawn a image for you to display on your card. Random blend will blend between them like linear blend randomly. I've never used that. I only use random. So subimages horizontal is 2, and subimages vertical is 2, because if you look here, we have 1, 2 on the horizontal and 1, 2 on the vertical. If we had another row, we would add another row, horizontal or vertical. You don't have to worry about those 2 bottom ones. These are the important things. All right, so now, it's still very difficult to see. I think we need to change our size a little bit. We're going to make this 100 and this 75, just to make it easier to see, because our lightning is so thin compared to our thick, round thing. There we go. But you can see it's all the same piece of lightning. What gives? We have it set to random, we have it set to SubUV. Well, you have to go down to SubUV and add subimage index. This is how we tell Unreal what to change between. So you always want to go from 0 to 1. 0 is the beginning of your flipbook. 1 is the end of your flipbook. Because it's video game land, 0, the first thing is always 0. So we want to randomly select from in a range from our first 0 picture to our 0, 1, 2, 3, third picture. So the end of our flipbook is going to be image number 3. And now, as you can see, well, it's a little hard to see because they're so fast and so they're just so fast, really. It's hard to see that it is selecting from a bunch of different sprites. But when I slow it down, you can make it out. The thing with stuff like lightning is because it's not actually moving, if you slow it down too much, it gets really obvious that you're just scaling up a lightning picture. But now, there we go. That's a very simple way to use a flipbook or a sprite sheet or a SubUV image, whatever you would like to call it. Actually going to make these very wide, because lightning is cool, and yeah, there we go. Zap, zap. Now it has that burst of lightning and energy. Whoa, it's an impact. That looks pretty good. So that's SubUV. It's an easy way to add more variety to a single emitter in one texture. Just keep playing this because I think it actually looks pretty cool, and I'm glad that I have it. I'm going to talk about one more thing before I say that this is a pretty good introduction video. Let's move this into the ground. Play it. Move it more into the ground because you can't quite see what I want to show. Alright, so if you look here, you can see that the border between the sprite and the ground is this really ugly sharp line where it's clipping. I don't like that. I think it's ugly. I want it to, when it hits the ground, I want it to fade nicely into the ground. If you know anything about materials, you know what I'm going to do. I'm going to add depth fade. It's really easy. We're just going to go in here and we're going to type it, or this is our master material. We're going to type in depth fade. We're going to plug this into our opacity and plug it into our attribute opacity. And I'm going to add a scalar parameter called depth fade power. And I'm going to plug this. Actually, no, let's just name this depth fade, not power. Distance. There we go. Plug that in. We're going to set the default value on this to 75, which is a little less than the default on the actual node. We're just going to save that, inherit it down to all of our instances. And now, if we wanted something to fade more or less, we could change that in the material instance. I'm not going to, because I think 75 is a good number for everything. And now, look, our ugly line is gone. It fades nicely into the ground. Wonderful. So yeah, that's a simple impact effect. This is only 4 emitters, so it's pretty bare bones. We can change the name of lines to lightning, which is a better name than lines. So yes, that is a basic introduction to Cascade. You can make pretty cool looking stuff with these basics. I think this is a pretty cool looking stuff that I made. Yeah. Make cool stuff.